last time we were together, fundamental theorem of algebra. If I have a polynomial like y equals x cubed plus 4x squared plus 3x plus 12, how many zeros or solutions can this polynomial have? We have up to 3, right?
Yeah.
Okay, now, and actually, I'm going to say up to 3 real solutions, okay? Now, I didn't explain this to you, and I didn't go into the history of imaginary numbers. This is your note packet. 5.6. Yes, sir. Question? Question, Martin? Or are you stretching? All right. Anyway, you have up to 3 real solutions. You're always going to have, if you incorporate imaginary number system, you're going to have exactly 3 solutions. Okay, the highest degree. So you can have up to 3 real solutions. You have 3 solutions if you include imaginary number system. And like I said, I didn't go into the history of it. I didn't think you guys really cared that much about it. But all right, so in order to find the solutions for every polynomial, we have a little process here, okay? And our process is this process here, steps 1 through 4. Okay, this is a process to determine what all these zeros are for a polynomial. Now, when I say zeros, I mean solutions, roots, x-intercepts. They're called a lot of different things. Okay. By the way, with solutions or zeros or x-intercepts, what's my y value? When they cross that x-axis, what's the y value? That's right, y equals 0. You guys are great. Okay, now, here's the little notes about this. You will find the same number of solutions as the number of the degree. So like my example up here, my degree is 3, so that would be 3 solutions. That's why I had 3 solutions, right? And here's another note. If you graph the polynomial and the function seems to bounce off the x-axis, that means the solution shows up more than once. It's called a multiplicity. Now, back when we were together 3-4 months ago, our last day of school, we had certain problems where I had x equal 3, x equal 3, x equal 5. Remember? Well, that 3 would be a multiplicity of 2. Okay? Just a new way of saying it. Okay, you ready, kids? We're going to do some examples. Are you ready? Are you ready? Are you ready? Huh? Yes, sir. What? All right, so, guys, this is going to be on your quiz Friday, so focus. You have a quiz Friday. All right, so we need a quiz. We haven't had a quiz in like 6 years. Whoa. All right, I'm not going to do number one. It's too easy. So number two, step one, use a graphing calculator. Use a graphing calculator to determine an easy to spot x-intercept. So I'm going to graph this. Number two, I got my graphing calculator. I'm going to put my y equals button there, and I got x raised to the 3 minus x squared plus 49x minus 49. I'm going to graph this. And hey, look, lo and behold, it looks like my solution or zero there, my x-intercept, is at the number one. I need to make sure. So I'm going to use second table. Now remember, my x-intercept has a y value of 0. So I look at here, and lo and behold, 1 does have a y value of 0. So one of my solutions here is x equal 1. Now I got to find 2 more solutions, right? Because it's degree 3, that means I have 3 solutions. Okay, so step 2. Divide the original polynomial by the 0 using synthetic division. Wonderful. Okay, so I'm going to use synthetic division to find another 0. Let's see, that means I need a backward cell and a summation line. Okay, my 0 or divisor is 1. What are the coefficients of my polynomial? 1, negative 1, 49, and negative 49. So remember, I'm going to add these together, right? Okay, bring down the 1. Take 1 times 1, I get 1. Negative 1 plus 1, 0. 0 times 1 is 0. 49 plus 0, 49. 49 times 1 is 49. Negative 49 plus 49 is 0. Okay, so let's say I started with x cubed. I divided out an x, so I'm left with 1x squared plus 0x to the first plus 49. Now, I'm going to get rid of that 0x. I don't like it. It bothers me. So I just have x squared plus 49. Now, what? Huh? Huh? What? There's a what? A what? 49. No. That, well, it's x to the 0.
Because the 1, 0, 49,
1, 0. I got my 0 there. 49. There's my 49. Well, if you want a plus 0, that's fine. It still comes out to x squared plus 49. Squared plus 49. X what? Plus 7? X plus 7 and what? X plus 7. Let's see, that gives me x squared plus 7x plus 7x plus 49 That gives me x squared plus 14x plus 49. Nope, that's not it. Anybody else? Plus and minus? Minus, minus? All right, let's try the plus minus first. X plus 7, x minus 7. That gives me, let's see, x squared. Zeroes out my x, but gives me minus 49. Oh, that doesn't work. What do you want? Negative, negative? Okay, x minus 7, x minus 7. Let's see, x squared. See, negative 7x, negative 7 is negative 14x, and plus 49. Nope, that doesn't work. Anything else? Anybody? Anyone? 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 Okay, what factors every quadratic polynomial? The quadratic formula. Very good. So we have quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, what's my a? Same problem. Still working on it. We haven't found the zeros yet. A is what? A is 1. B is what? Nope, that's C. That's C. Yeah, B is 0. Okay, let's plug it in and work it out. So x equals negative b, negative 0, plus or minus square root of 0 squared minus 4 times a, which is 1, times c, which is 49, all over 2 times a, which is 1. Okay, we have to do the discriminant first. All right, 0 squared is just 0. So the square root of 0 minus 4 times 49. Let's see, 36, 3, 16, 196. What's the square root of negative 196? How about this? What's the square root of 196? That's right, 14. Very good, children. Now, what's the square root of negative 1? Come on, you can do this. Square root of negative 1. What is it? No? Square root of negative 1. Gentlemen playing video games in the back. Anybody know the square root of negative 1? No. Imaginary, what is it? I. Beautiful. 14i. Square root of negative 1 is I. Okay, so we're going to put 14i back into our problem. So x equals, I'm not going to put the negative 0 there because it's just 0, plus or minus 14i over 2 times 1 is 2. So, yeah, from this, we get our other two x's, our solutions, right? We have positive 14 divided by 2 is 7i. Negative 14i divided by 2 is negative 7i. So there's my other two solutions. X equal 1, x equal positive 7i, and x equal negative 7i. And that's my answer, kids.
1 second.
Now, you can't sit there and tell me that that's not fun. That's some fun stuff. Fun, fun, fun. There we go. Wait till the next page. We'll get some more fun. All right. Problem number 4. Are you ready, kids? Huh? Are you ready? Are you ready, kids? All right, number 4. Step 1. Step 1. Use a graphing calculator to determine an easy-to-spot x-intercept. Okay, so using your calculator, let's see, we have x to the 4th plus 6x to the 3rd plus 14x squared plus 54x plus 45. You ready? Graph it. I know this is the suspenseful part. Graph that. Ooh. All right. Yeah, I'm pretty sure that's -1. Let's check our chart. Let's see, -1, and sure enough, I have a 0 there. Okay, so one of my solutions, x equal -1. Okay, we got an easy solution. Step 2. Let's see, what is step 2? Divide the original polynomial by that 0 using synthetic division. Okay, synthetic division. There we go. Backwards up. Summation line. All right, divisors -1. Coefficients 1, 6, 14, 54, 45. Okay, we're going to add these. We're going to bring down the 1. 1 times -1, -1. 6 plus -1, 5. 5 times -1, -5. 14 plus -5, 9. 9 times -1, -9. 54 plus -9, 45. 45 times -1, -45. 45 plus -45, 0. Okay. Let's see, we divided by an x. I'm back down to a 1x cubed. I have a plus 5x squared, a plus 9x, and a plus 45. Now, can anybody factor that? Huh? Anyone? I suggest we try synthetic division again, because I don't think anyone can factor that. Okay, so we're going to need a divisor, summation line. I would go back to your calculator. Let's go back to our graph here. I think there's another one we can pick up pretty easy. Let's see, 1, 2, 3, 4. Looks like -5. I'm going to check it. I'm going to check to make sure it's a 0, and sure enough, it is an x-intercept. So, x equals -5 is another one. So I'm going to put -5 in there. By coefficients, 1, 5, 9, 45. Bring down the 1. We're going to add those. 1 times -5. That's right, -5. 5 plus -5, 0. 0 times -5, 0. 9 plus 0, 9. 9 times -5, -45, 45, 0. Okay, now where we're at. We were at x cubed, so now we're at 1x squared plus 0x plus 9. So I have x squared plus 9. Can anybody factor that now? We're down to a quadratic. So what are we going to have to use? That's right, it's quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. What's my a? That's right, kids. 1. What's b? 0. C is. Okay, let's plug it in. See, x equals -b, which is -0, plus or minus the square root of 0 squared minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. Hey, discriminant. So we have the square root of -4 times 9 is -36. What does that equal? 6 what? 6i. Wonderful. Okay, so my other two roots here. X is going to equal 6i divided by 2 is 3i. And negative 6i divided by 2 is -3i. So here's my answer. Isn't that cool? Fun, fun, fun until you go to sleep. What? To find the zeros. Okay, on your practice packet, you have a 5.6 practice sheet. You can do your 5.6 practice sheet. That would be after the bookwork. Finding the zeros. The solution. Yeah, you could use that for finding or something like that. So you've got 8 problems to do. There you go. Fundamental theorem of algebra worksheet 2. Let's see, fundamental theorem of algebra worksheet 2. Fundamental theorem of algebra worksheet 2. And I assign that assigned on 2/19/19. Questions, comments, concerns? You guys need help? Huh? Anyone? Good.